Welcome! In this demo, we are going to demonstrate one of the Kubernetes most popular features, autoscaling. We are also going to make use of Prometheus project to set up a monitoring stack, create a nice looking visualization with Grafana, and check how the autoscaling does its magic in the real time. Links to all used tools and guides are provided here in the video's description, so you can check it out. Now let's start with some concepts. Why is autoscaling a convenient feature to have? It is because it allows us to set up scaling automatically and quickly. It makes real-time smart scaling decisions. It automatically maintains performance and efficiency. Now, after knowing this, you must be imagining how does the autoscaling work. So let me take you quickly through it. As you can see in this picture, the horizontal pod autoscaler is implemented as a Kubernetes API resource and controller. The resource determines the behavior of controller, and the controller periodically adjusts the number of replicas in a replication controller or deployment to match the observed average CPU utilization to the target specified by the user. For this demo, we will see when there is no load, there is only one active pod, and the number of pods will adjust to the necessary level as we increase or decrease the load. For monitoring, we are going to use Prometheus project. This repository collects Kubernetes manifests, Grafana dashboards, and Prometheus rules to provide easy to operate end-to-end Kubernetes clustering monitoring. It is intended to be used as a library, so we will just clone and install it in our cluster. So now let's get started.
To set up the monitoring stack, we go to the Kubernetes repository and follow the quick start guide. In there, we follow the instructions to create all namespaces and containers necessary for it to work. We can make use of the watch command to follow the status of the deployment of the monitoring containers. As we follow the instructions, we have to make sure that all commands are correctly executed and all containers are properly initialized. As we can see, some containers may take a minute or two to be created and start running. Next, we expose our Prometheus and Grafana services by using the kubectl port forward command. We can check now that they are accessible by entering the address in our browser. Once we have access to the Grafana service, we will import a previously created dashboard to monitor our autoscale deployment. Since we haven't set up our deployment, the dashboard will receive no data just yet. Now, we go on to set up our autoscaling deployment by following the walkthrough provided by the Kubernetes documentation. Here, we will set up a deployment of a simple web server. With this command, we set up an autoscaler on the deployment and specify the target CPU utilization and minimum and maximum number of replicas. We can check now that our Grafana dashboard has started to receive and display some information about our deployment. Next, we generate some load towards the web server. After a minute or two, we can go to the Grafana dashboard and see the current status of the deployment, such as the number of replicas, current total CPU usage, and the network traffic. That should change over time.
Hope you enjoyed this demo. We have shown how horizontal plot autoscaler is used in Kubernetes and visualized it using Grafana and Prometheus via Kubernetes project. Do you want to practice yourself? Do you find it really interesting? Then make sure to check out our implementation in Katakoda prepared exclusively for you in the video description below. Please do check out that. Thank you so much.